Welcome to this comprehensive video on Earth's atmosphere. We will explore the composition, evolution, and chemistry of the air we breathe, from the early Earth to today's greenhouse crisis. Chapter 1 covers the early atmosphere. When Earth first formed, it had no atmosphere. As it cooled, volcanic activity released gases, forming an atmosphere primarily of carbon dioxide and water vapor, but virtually no oxygen. Volcanic activity was the engine that built the early atmosphere, a process known as degassing. The most abundant gases released were carbon dioxide and water vapor. Nitrogen was released in smaller quantities but accumulated steadily due to its unreactive nature. As the Earth cooled below 100 degrees Celsius, water vapor condensed into liquid water, forming the oceans. This was a planetary-scale event that significantly reduced atmospheric carbon dioxide, setting the stage for life. Carbon dioxide levels fell dramatically over billions of years due to several processes. These included dissolution into the oceans, formation of carbonate rocks from marine organisms, and the burial of organic matter, leading to the formation of fossil fuels. The emergence of photosynthetic organisms like cyanobacteria marked a turning point. Photosynthesis uses carbon dioxide and water to produce glucose and, critically, oxygen as a byproduct. This led to the Great Oxidation Event, where oxygen levels rose sharply. Chapter 2 focuses on today's atmosphere. Its composition is dominated by 78% nitrogen and 21% oxygen. The remaining 1% includes argon, water vapor, and carbon dioxide. Remember the quote 78211 rule. Greenhouse gases absorb and re-emit infrared radiation, trapping heat near Earth's surface. This natural greenhouse effect is essential, as without it, the average temperature would be minus 18 degrees Celsius. Key human-impacted greenhouse gases include carbon dioxide, methane, water vapor, and nitrous oxide. The greenhouse effect involves solar radiation warming the surface, which then emits infrared radiation. Greenhouse gases absorb and re-emit this heat. The enhanced greenhouse effect, caused by human activities increasing gas concentrations, is driving global warming. Chapter 3 explains global warming. It is the long-term rise in Earth's average temperature due to increased greenhouse gases from human activities. This warming is unequivocal. The international target is to limit warming to 1.5 degrees Celsius above pre-industrial levels. The effects of climate change are widespread and interconnected. They include rising sea levels due to thermal expansion and melting ice, more frequent and intense extreme weather events, loss of biodiversity, and threats to food and water security. The main sources of increasing greenhouse gases are human activities. These include burning fossil fuels, deforestation, agricultural practices like livestock rearing, and waste management in landfills. These sources collectively account for the dramatic rise in CO2 and other greenhouse gases since the Industrial Revolution. A carbon footprint is the total greenhouse gas emissions, direct and indirect, produced over a period. Major contributors for individuals include transport, home energy use, diet, especially meat and dairy, and the consumption of manufactured goods. Reducing carbon emissions requires both mitigation and adaptation. Key strategies include transitioning to renewable energy, using electric vehicles, reforestation, improving energy efficiency, adopting dietary changes, and implementing strong policy and carbon pricing mechanisms. Chapter 4 introduces atmospheric pollutants, substances that cause direct, localized harm. Pollutants are classified as primary, emitted directly from a source, or secondary, formed by reactions in the atmosphere. Key GCSE pollutants are particulates, sulfur dioxide, nitrogen oxides, and carbon monoxide. Sources include fossil fuel combustion and industrial processes. Particulates, tiny solid or liquid particles, are produced by the incomplete combustion of fuels. PM 2.5 are particularly dangerous as they penetrate deep into the lungs and bloodstream. Globally, air pollution from particulates causes millions of premature deaths each year. Sulfur dioxide is produced from burning fuels containing sulfur impurities, like coal. In the atmosphere, sulfur dioxide reacts with water to form sulfuric acid, which falls as acid rain. Acid rain acidifies water, damages forests, and erodes monuments, often traveling internationally. Nitrogen oxides, or NOU, form when nitrogen and oxygen react at the high temperatures found in engines. Nitrogen dioxide contributes to acid rain and photochemical smog. It also poses respiratory health risks and can cause eutrophication in ecosystems. Key exam questions focus on the early atmosphere, greenhouse effect, acid rain, and atmospheric pollutants. For success, memorize exact gas percentages, use precise scientific terminology, and link the cause of pollution to its specific effect. To recap, Earth's atmosphere evolved from volcanic gases to its current composition, driven by cooling and photosynthesis. The natural greenhouse effect is vital, but human activity has enhanced it, causing global warming. Remember the difference between the essential and the enhanced greenhouse effect.